Okay, we're going to look at the 5.1, which is fundamental trig identities. So if you recall, the tangent of theta is equal to the sine of theta over the cosine of theta, or the y over the x, or the rise over the run. If we look at it on the unit circle, if I had a circle, this point right here, I would be moving over x and up y. So this would be my y and my x, okay? And that's the tangent, so the opposite over the adjacent. So what an identity is that when I input anything for theta, this relationship is true. So it's not good for just one angle. This calculation, sine theta over cosine theta, will always equal tangent theta, no matter what angle I put into the equation. So I'm going to try it. I'm going to do the sine in radians of 1 over the cosine of 1. And I'm going to see, does that equal the tangent of 1? And when I put it in my calculator, these values are equal. Try another, okay? And another, and another, and make sure that this is true. If you ever find one that doesn't work, then you've disproved this identity. So this identity has to work for every angle that you put in. Okay, so we're going to do another one. So what is the equation of any triangle on the unit circle? So again, remember, that's bad circle. Okay, triangle right here. Let's see, this is an x length and a y length and an r length. So if I have x squared plus y squared is equal to r squared, and then my r in a unit circle is equal to 1, so x squared plus y squared is equal to 1. We know that x is equal to the cosine of theta, so I can replace that, plus y is equal to the sine of theta, and that's equal to 1. So this is another way that we can represent the lengths of a triangle on the unit circle, or any ordered pair on the unit circle. So this is an identity. We're going to try a couple here. So if we have the cosine of 1 squared plus the sine of 1 squared, does that equal 1? Try another one. Does that equal 1? Type those into your calculator. Okay, the fundamental trig identities. These are, first we have our reciprocal identities. So what's the reciprocal of sine? Oh yeah, that's 1. That's cosecant, so it's 1 over the cosecant of u, or theta, or whatever input you're using. Secant's the reciprocal of sine, so that would be 1 over sine u. Cosine is 1 over secant u, 1 over cosine u. Tangent is 1 over cotangent u, and cotangent is 1 over tangent u. So in your calculator right now, try this. We're going to do, if I wanted to figure out the secant of 3, there is no secant button in my calculator. We already know that cosine is the reciprocal, so I can put it in as 1 over the cosine of 3, and these will give me the same values. Yeah, I know, amazing. So in an equation, I can replace the secant, the cosine of u, with the 1 over the secant of u if I wanted to. Okay. All right, the next relationships are the quotient identity. This is kind of like from example 1. So tangent, another way to write tangent is sine u over cosine u. An example of cotangent that we can rewrite, since it's a reciprocal of tangent, is cosine u over sine of u. Okay? Next, Pythagorean identities. So we had the sine of u squared times the cosine of u squared. You will also see these written like this: sine u squared over cosine squared u equals 1. They mean the same thing. Okay? So sometimes it's nice to rewrite these in a different way. So if I subtract sine from both sides, sine squared u, I get 1 minus sine squared u is equal to cosine squared u. Sometimes it's nice to rewrite them. If I subtracted cosine u from both sides, we'd get 1 minus cosine squared u is equal to sine squared u. Okay. So that's one Pythagorean identity. Next, we're going to look at this one. This is another Pythagorean identity. 1 plus tangent squared u equals secant squared u. Let's talk about how we get that really quick. I think we have a little space up here. So sine squared u plus cosine squared u is equal to 1. We know that's true for all angles. If I wanted to turn cosine into a 1, what I would do is divide both sides by cosine squared u. And don't forget this term. Okay. Hey, what is sine squared u over cosine squared u? Oh, quotient property tells me that this is tangent squared u plus, this turns into a 1, and then quotient property tells me 1 over cosine squared u is equal to secant squared u. So this is another way to write this Pythagorean identity. Okay, we can rearrange the equation to subtract the 1. We can also see the equation sometimes like this: secant squared u minus tangent squared u is equal to 1. Okay. All right. The last Pythagorean identity that we see is this one. We get this one the same way as how we get 1 plus tangent squared u equals secant squared u. So we're going to start with our regular old sine squared plus cosine squared equals 1. And then we're going to divide everything by sine squared u this time. Okay, this goes to 1. Okay, plus quotient property tells me that this is, cotangent squared u is equal to the cosecant, the reciprocal of sine, squared u. And that's how we get that. So sometimes we like to rearrange it. So this one we subtracted 1 from both sides. Let's go ahead and write this as 1 equals, and we get cosecant squared u minus cotangent squared u. I really highly recommend that you write down all the different rearrangements of these equations. It helps a lot. Okay. The next identities, so these are true for every angle that you input, are the cofunction identities. So if you see sine of pi over 2 minus theta, you can replace that with the cosine of theta. It's pretty handy. Write these down. Write these down. Okay? Lastly, we have even odd functions. So if you remember, sine is an odd function. So the sine of negative u is equal to the negative sine of u. And because cosecant is its reciprocal, it is also an odd function. Cosine's an even function, so the cosine of negative u is equal to the cosine of positive u. And same with secant, also even. Tangent is odd, so the tangent of negative u is equal to the negative tangent u. And cotangent is also odd, so this is equal to the negative tangent of positive u. Okay, and those are